1.1.2. Use variables and algebraic symbols. In algebra, we use a letter of the alphabet to represent a number whose value may change. We call this a variable, and letters commonly used for variables are x, y, a, b, c. A variable. A variable is a letter that represents a number whose value may change. A number whose value always remains the same is called a constant. B. Constant. A constant is a number whose value always stays the same. To write algebraically, we need some operation symbols as well as numbers and variables. There are several types of symbols we will be using. There are 4 basic arithmetic operations: addition, subtraction, multiplication, and division. We'll list the symbols used to indicate these operations below. C. Operation symbols. Operation. Notation. Say. The result is 1. Addition. A plus B. A plus B. The sum of A and B. 2. Subtraction. A minus B. A minus B. The difference of A and B. 3. Multiplication. A dot B. A times B. A multiplied by B. A multiplied by B. A multiplied by B. A times B. The product of A and B. 4. Division. A divided by B. A over B. A over B. A divided by B. A divided by B. The quotient of A and B. A is called the dividend and B is called the divisor. When two quantities have the same value, we say they are equal and connect them with an equal sign. D. Equality symbol. A equals B is read. A is equal to B. The symbol equals is called the equal sign. On the number line, the numbers get larger as they go from left to right. The number line can be used to explain the symbols less than and greater than. E. Inequality. A left angle bracket B is read. A is less than B. A is to the left of B on the number line. A right angle bracket B is read. A is greater than B. A is to the right of B on the number line. The expressions A left angle bracket B or A is greater than B can be read from left to right or right to left, though in English we usually read from left to right. In general, A is less than B is equivalent to B is greater than A. For example, 7 is less than 11 is equivalent to 11 is greater than 7. A is greater than B is equivalent to B is less than A. For example, 17 is greater than 4 is equivalent to 4 is less than 17. F. Inequality symbols. Inequality symbols. Words. A not equal to B. A is not equal to B. A less than B. A is less than B. A less than or equal to B. A is less than or equal to B. A greater than B. A is greater than B. A greater than or equal to B. A is greater than or equal to B. Grouping symbols in algebra are much like the commas, colons, and other punctuation marks in English. They help identify an expression, which can be made up of number, a variable, or a combination of numbers and variables using operation symbols. We will introduce 3 types of grouping symbols now. G. Grouping symbols. 1. Parentheses. Left parenthesis or open parenthesis. Right parenthesis or closed parenthesis. 2. Brackets. Left square bracket or open square bracket. Right square bracket or closed square bracket. 3. Braces. left curly bracket or open curly bracket, right curly bracket or closed curly bracket. Here are some examples of expressions that include grouping symbols. We will simplify expressions like these later in this section. 8 times, open parenthesis, 14, minus, 8, closed parenthesis. 21, minus, 3, times, open square bracket, 2, plus, 4, times, open parenthesis, 9, minus, 8, closed parenthesis, closed square bracket. 24 divided by, open curly bracket, 13, minus, 2, times, open square bracket, 1, times, open parenthesis, 6, minus, 5, closed parenthesis, plus, 4 closed square bracket, closed curly bracket. What is the difference in English between a phrase and a sentence? A phrase expresses a single thought that is incomplete by itself, but a sentence makes a complete statement. A sentence has a subject and a verb. In algebra, we have expressions and equations. Expression. An expression is a number, a variable, or a combination of numbers and variables using operation symbols. Expression. Words. English phrase. 3 plus 5. 3 plus 5. The sum of 3 and 5. N minus 1. N minus 1. The difference of n and 1. 6.7. 6 times 7. The product of 6 and 7. X over y. X divided by y. The quotient of x and y. Notice that the English phrases do not form a complete sentence because the phrase does not have a verb. An equation is two expressions linked by an equal sign. When you read the words the symbols represent in an equation, you have a complete sentence in English. The equal sign gives the verb. Equation. An equation is two expressions connected by an equal sign. Equation. English sentence. 3 plus 5 equals 8. The sum of 3 and 5 is equal to 8. N minus 1 equals 14. N minus 1 equals 14. 6.7 equals 42. The product of 6 and 7 is equal to 42. X equals 53. X is equal to 53. Y plus 9 equals 2y minus 3. Y plus 9 is equal to 2y minus 3. Suppose we need to multiply 2 9 times. We could write this as 2 dot 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 2. This is tedious and it can be hard to keep track of all those 2's, so we use exponents. We write 2 dot 2 dot 2 as 2 cubed, and 2 dot 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 2 as 2 to the 9th power. In expressions such as 2 cubed, the 2 is called the base, and the 3 is called the exponent. The exponent tells us how many times we need to multiply the base. 2 to the 3rd power means, multiply 2 by itself, 3 times, as in 2 dot 2 dot 2. We read 2 to the 3rd power as 2 to the 3rd power or 2 cubed. J. Exponential notation. We say, 2 cubed is in exponential notation, and 2 dot 2 dot 2 is in expanded notation. A to the nth power means multiply a by itself n times. A is the base. N is the exponent. A to the nth power equals a dot a dot a dot a up to n factors. The expression a to the nth power is read a to to the nth power. While we read a to the nth power as a to the nth power, we usually read a to the second power, a squared, a to the third power, a cubed. We'll see later why a to the second power and a to the third power have special names. Table 1.1 shows how we read some expressions with exponents. Expression. In words: 7 to the second power, or 7 squared. 5 to the third power, or 5 cubed. 9 to the fourth power. 12 to the fifth power. Table 1.1. 1.1.3. Simplify expressions using the order of operations. To simplify an expression means to do all the math possible. For example, to simplify 4.2 plus 1, we would first multiply 4.2 to get 8 and then add the 1 to get 9. A good habit to develop is to work down the page, writing each step of the process below the previous step. The example just described would look like this. 4.2 plus 1. 8 plus 1. 9. By not using an equal sign when you simplify an expression, you may avoid confusing expressions with equations. A. Simplify an expression. To simplify an expression, do all operations in the expression. We've introduced most of the symbols and notation used in algebra, but now we need to clarify the order of operations. Otherwise, expressions may have different meanings, and they may result in different values. For example, consider the expression 4 plus 3.7. Some students simplify this, getting 49, by adding 4 plus 3 and then multiplying that result by 7. Others get 25 by multiplying 3.7 first and then adding 4. The same expression should give the same result. So mathematicians established some guidelines that are called the order of operations. How to use the order of operations. Step 1. Parentheses and other grouping symbols. Simplify all expressions inside the parentheses or other grouping symbols, working on the innermost parentheses first. Step 2. Exponents. Simplify all expressions with exponents. Step 3. Multiplication and division. Perform all multiplication and division in order from left to right. These operations have equal priority. Step 4. Addition and subtraction. Perform all addition and subtraction in order from left to right. These operations have equal priority. Students often ask, how will I remember the order? Here is a way to help you remember. Take the first letter of each key word and substitute the silly phrase, "Please excuse my dear Aunt Sally." Parentheses, P, please. Exponents, E, excuse. Multiplication, division, M, D, my dear. Addition, subtraction, AS, Aunt Sally. It's good that my dear goes together, as this reminds us that multiplication and division have equal priority. We do not always do multiplication before division or always do division before multiplication. We do them in order from left to right. Similarly, Aunt Sally goes together and so reminds us that addition and subtraction also have equal priority and we do them in order from left to right. Example 1.4. Simplify. 18 divided by 6 plus 4 times, open parenthesis, 5 minus 2, closed parenthesis. Solution. 18 divided by 6 plus 4 times, open parenthesis, 5 minus 2, closed parenthesis. Parentheses? Yes, subtract first. 18 divided by 6 plus 4 times, open parenthesis, 3, closed parenthesis. Exponents? No. Multiplication or division? Yes. Divide first because we multiply and divide left to right. 3 plus 4 times, open parenthesis, 3, closed parenthesis. Any other multiplication or division? Yes. Multiply. 3 plus 12. Any other multiplication of division? No. Any addition or subtraction? Yes. Add. 15. Try it 1.7. Simplify. 30 divided by 5 plus 10 times, open parenthesis, 3 minus 2, closed parenthesis. Try it 1.8. Simplify. 70 divided by 10 plus 4 times, open parenthesis, 6 minus 2, closed parenthesis. When there are multiple grouping symbols, we simplify the innermost parentheses first and work outward. Simplify. 5 plus 2 cubed plus 3 times, open square bracket, 6 minus 3 times, open parenthesis, 4 minus 2, closed parenthesis, closed square bracket. Solution. 5 plus 2 cubed plus 3 times, open square bracket, 6 minus 3 times, open parenthesis, 4 minus 2, closed parenthesis, closed square bracket. Are there any parentheses or other grouping symbols? Yes. 5 plus 2 cubed plus 3 times, open square bracket, 6 minus 3 times, open parenthesis, 4 minus 2, closed parenthesis, closed square bracket. Focus on the parentheses that are inside the brackets. Subtract. 4 minus 2 equals 2. 5 plus 2 cubed plus 3, open square bracket, 6 minus 3 times, open parenthesis, 2 closed parenthesis, closed square bracket. Continue inside the brackets and multiply. 3 times 2 equals 6. 5 plus 2 cubed plus 3 times, open parenthesis, 6 minus 6, closed parenthesis. Continue inside the brackets and subtract. 6 minus 6 equals 0. 5 plus 2 cubed plus 3 times 0. The expression inside the brackets requires no further simplification. Are there any exponents? Yes. Simplify exponents. 2 cubed equals 8. 5 plus 8 plus 3 times 0. Is there any multiplication or division? Yes. Multiply. 3 times 0 equals 0. 5 plus 8 plus 0. Is there any addition of subtraction? Yes. Add. 5 plus 8 equals 13. 13 plus 0. Add. 13. Try it 1.9. Simplify. 9 plus 5 cubed minus, open square bracket, 4 times, open parenthesis, 9 plus 3, closed parenthesis, closed square bracket. Try it 1.10. Simplify. 7 squared minus 2 times, open square bracket, 4 times, open parenthesis, 5 plus 1, closed parenthesis, closed square bracket. B. Evaluate an expression. In the last few examples, we simplified expressions using the order of operations. Now we'll evaluate some expressions, again following the order of operations. To evaluate an expression means to find the value of the expression when the variable is replaced by a given number. Evaluate an expression. To evaluate an expression means to find the value of the expression when the variable is replaced by a given number. To evaluate an expression, substitute that number for the variable in the expression and then simplify the expression. Example 1.6. Evaluate when x equals 4. A. X squared. B. 3 to the power of x. C. 2x squared plus 3x plus 8. Solution. A. X squared. Replace x with 4. 4 squared. Use definition of exponent. 4. 4. Simplify. 16. B. 3 to the power of x. Replace x with 4. Use definition of exponent. 3. 3. 3. 3. Simplify. 81. C. 2x squared plus 3x plus 8. Replace x with 4. 2 times, open parenthesis, 4, closed parenthesis, squared, plus 3 times, open parenthesis, 4, closed parenthesis, plus 8. Follow the order of operations. 2 times, open parenthesis, 16, closed parenthesis, plus 3 times, open parenthesis, 4, closed parenthesis, plus 8. 32, plus 12, plus 8. Equals 52. Try at 1.11. Evaluate when x equals 3. A. X squared. B. 4 to the power of x. C. 3x squared plus 4x plus 1. Try at 1.12. Evaluate when x equals 6. A. X cubed. B. 2 to the power of x. C. 6x squared minus 4x minus 7.